Yes, it is permissible to divide the strands of a neutral conductor and utilize two holes on a neutral busbar if the existing holes prove too small for the entire conductor. However, adherence to the National Electrical Code, commonly referred to as the NEC, is crucial for safe and code-compliant installation. NEC Article 310.15 B3 stipulates that conductors smaller than 6 American wire gauge, or AUG, must be grouped together and taped or tied in an approved manner. This regulation implies that the strands of a neutral conductor smaller than 6 AWG must be bundled and secured together before being connected to the busbar. NEC Article 250.120 mandates that the neutral conductor shall have the same ampacity as the ungrounded conductors. This implies that the combined ampacity of the strands used to connect to the busbar must be equal to or greater than the ampacity of the ungrounded conductors in the circuit. NEC Article 110.14 prohibits splicing conductors unless conducted in accordance with the NEC. However, dividing the strands of a neutral conductor and using two holes on a busbar is not considered splicing as long as the strands are properly bundled and secured together. Several additional considerations should be taken into account to ensure a safe and effective installation. Firstly, use a busbar that is rated for the number of strands being used. Secondly, ensure that the strands are securely fastened to prevent them from spreading or coming loose. Thirdly, use a torque wrench to tighten the bolts or screws that secure the strands to the busbar. Fourthly, follow the manufacturer's instructions for the specific busbar being used. To elaborate further on the considerations mentioned, understanding the ampacity requirements outlined in the NEC is paramount. The ampacity of a conductor refers to its current carrying capacity, and it is essential to ensure that the divided strands collectively meet or exceed the ampacity of the ungrounded conductors in the circuit. This is crucial to prevent overheating and potential fire hazards. When bundling the strands, use appropriate electrical tape or approved cable ties to create a secure and compact bundle. This not only ensures compliance with NEC Article 310.15 B3 but also helps maintain the integrity of the connection over time. Secure fastening is essential to prevent the strands from coming loose due to vibration or other factors. Use appropriate hardware such as screws or bolts that are specifically designed for electrical connections. Ensure that the hardware is properly tightened to provide a reliable and long-lasting connection. The use of a torque wrench is highly recommended to ensure that the hardware is tightened to the manufacturer's specified torque. Over-tightening can damage the hardware or the busbar, while under-tightening can result in a loose connection. A torque wrench allows for precise tightening, ensuring a secure and reliable connection. Always refer to the manufacturer's instructions for the specific busbar being used. The manufacturer's instructions provide valuable information about the busbar's ratings, installation procedures, and torque specifications. Following these instructions is crucial to ensure safe and compliant installation. In addition to these considerations, it is important to inspect the busbar for any signs of damage or corrosion before making the connection. If any damage is found, the busbar should be replaced before proceeding. Proper grounding is also essential for electrical safety. Ensure that the busbar is properly grounded to provide a path for fault current to flow back to the source. This helps protect against electrical shock and equipment damage. When working with electrical systems, always follow safe work practices. Wear appropriate personal protective equipment such as gloves and eye protection, and energize the circuit before making any connections. If you are not comfortable working with electrical systems, it is best to consult a qualified electrician. To expand on the NEC articles mentioned, Article 310.15 B3 provides specific guidelines for grouping conductors, especially those smaller than 6 AWG. The requirement to tape or tie conductors in an approved manner ensures that the strands are kept together, preventing them from separating or becoming loose. This is particularly important when dividing the strands of a neutral conductor, as it helps maintain the integrity of the connection and ensures that the current is distributed evenly among the strands. Article 250.120 emphasizes the importance of matching the ampacity of the neutral conductor to that of the ungrounded conductors. This is crucial for preventing neutral overload, which can lead to voltage imbalances and equipment malfunction. By ensuring that the combined ampacity of the divided strands is equal to or greater than the ampacity of the ungrounded conductors, you can minimize the risk of neutral overload and maintain the stability of the electrical system. Article 110.14 addresses the general requirements for making electrical connections, including the prohibition of splicing conductors unless done in accordance with the NEC. While dividing the strands of a neutral conductor and using two holes on a busbar is not technically considered splicing, it is important to ensure that the connection is made in a safe and reliable manner. This includes properly bundling and securing the strands, using appropriate hardware, and tightening the hardware to the manufacturer's specified torque. In addition to the NEC articles mentioned, other relevant codes and standards may apply depending on the specific application and location. It is important to consult with a qualified electrician or electrical inspector to ensure that the installation meets all applicable requirements. When selecting a busbar for this application, it is important to choose one that is specifically designed for use with multiple conductors. These busbars typically have multiple holes or terminals that are sized to accommodate the required number of strands. It is also important to ensure that the busbar is rated for the voltage and current of the circuit. When making the connection, it is important to clean the conductors and the busbar to remove any dirt, corrosion, or other contaminants. This will help ensure a good electrical connection. Use a wire brush or other abrasive cleaner to clean the conductors, and use a clean cloth to wipe down the busbar. After cleaning the conductors and the busbar, apply a thin layer of antioxidant paste to the connection points. This will help prevent corrosion and ensure a long-lasting connection. When tightening the hardware, use a torque wrench to ensure that it is tightened to the manufacturer's specified torque. Over-tightening can damage the hardware or the busbar, while under-tightening can result in a loose connection. A torque wrench allows for precise tightening, ensuring a secure and reliable connection. After making the connection, inspect it carefully to ensure that all strands are properly secured and that there are no loose connections. Use a multimeter to verify that the connection is making good electrical contact. In summary, dividing the strands of a neutral conductor and using two holes on a neutral busbar is permissible under the NEC, provided that certain requirements are met. These requirements include bundling and securing the strands, ensuring that the combined ampacity of the strands is equal to or greater than the ampacity of the ungrounded conductors, and following safe work practices. By following these guidelines, you can safely and compliantly divide the strands of a neutral conductor and use two holes on a neutral busbar. Remember to always consult with a qualified electrician or electrical inspector if you have any questions or concerns. The information provided is for general guidance only and should not be considered a substitute for professional advice. The electrical work can be dangerous, and it is important to take all necessary precautions to ensure your safety. Furthermore, always consider the specific application and local regulations when making electrical installations. Local codes may have additional requirements or restrictions that must be followed. Proper planning and execution are essential for a safe and compliant electrical installation. In addition to the points already covered, it's crucial to emphasize the importance of documentation. Keep a record of the work performed, including the date, the materials used, and any relevant measurements or test results. This documentation can be helpful for future maintenance or troubleshooting. When working with electrical systems, it's always a good idea to have a second person present. This is especially important when working on live circuits. The second person can provide assistance in case of an emergency and can also help ensure that all safety precautions are followed. Before starting any electrical work, it's important to identify all potential hazards. This includes identifying live circuits, exposed wiring, and any other potential sources of electrical shock or fire. Take steps to mitigate these hazards before proceeding with the work. Always use the proper tools for the job. Using the wrong tools can damage the equipment or increase the risk of injury. Make sure you have the right tools for cutting, stripping, crimping, and tightening electrical connections. When stripping wires, be careful not to nick or damage the conductor. A nicked conductor can weaken the wire and make it more likely to break. Use a wire stripper that is properly sized for the wire gauge. When crimping connections, use a crimping tool that is specifically designed for the type of connector being used. Make sure the crimp is tight and secure. A loose crimp can cause the connection to overheat and fail. When tightening screws or bolts, use a torque wrench to ensure that they are tightened to the proper torque. Over-tightening can damage the hardware or the equipment, while under-tightening can cause the connection to loosen over time. After completing the work, inspect the installation carefully to ensure that everything is properly connected and secured. Use a multimeter to verify that the circuits are properly energized and that there are no shorts or ground faults. If you find any problems, correct them before energizing the circuit. Finally, remember to clean up the work area and dispose of any waste materials properly. Electrical work can be messy, so it's important to leave the area clean and safe. By following these additional tips, you can further enhance the safety and reliability of your electrical installations. Always remember that electrical work should be performed by qualified individuals who are familiar with the relevant codes and standards. If you are not comfortable working with electrical systems, it is best to consult a qualified electrician.